Okay, thanks everyone. Welcome to MESA's workshop on 1815.2. My name is Darcy Wheelis. I'm the Executive Director of the MESA Standards Alliance. You'll be hearing from me, as well as Francis Cleveland of Xanthus Consulting and Tyler Slay of PNNL. We're going to have plenty of time for Q&A at the end, so if you have a clarifying question, feel free to jump in. Otherwise, if you could hold your technical questions to the end, that would be great. You're also welcome to put questions in the chat. We will do our best to address them during this meeting. We may not be able to do so, so don't worry. We will try and follow up with you afterwards as best we can. Okay, today we're going to talk a little bit about MESA and who we are, and a little background on IEEE 1815.2. Francis will go into some detail on the new specification, and Tyler will talk to you about testing and certification, and then I'll give you some more information on joining MESA and staying engaged in this work as it continues to progress. Quickly, who is MESA? MESA is an industry association. It was created by utilities and vendors who wanted to take lessons learned from trying to integrate solar into the grid and apply it to energy storage and other DERs. Our mission is really to do just that, to accelerate the interconnection of DERs, and you do that by taking established standards. So what we have done with MESA DER, which is soon to be released 1815.2, is use the DMP3 with 61850 data models for interoperability and use those to meet 1547, IEEE 2800, and other energy storage and DER integration requirements. And where do we work? Just quick diagram that shows MESA's work. As I mentioned, we're really working in the DMP3 protocol and how SCADA talks to various how SCADA talks to various DERs. We also do some Modbus work and partner with SunSpec Alliance, and that's for the components of an energy storage system. We won't be covering that work today. We'll be focusing on the DNP3 work and 1815.2. This is Francis's slide, and it looks really complicated, but I'll simplify it for you. And in another webinar, we can go into deeper discussion of this. But we start with the utilities on the left. And then you have the aggregators and the facility management systems in the middle. And then the green boxes on the right are the individual DERs. And so if you're wondering, where does 1815.2 fit in? You can see where these orange circles are. That's where you'll see that these are all the different places where you can use 1815.2. I want to talk a little bit about what 1815.2 is and why it's needed. There are so many DERs on the grid already. If you think about the vast number that are coming in the future, you can understand why we need interoperability. We need a standard communications protocol to make it easy for utilities or other entities to integrate these different DERs into their systems. And it also makes it easier for manufacturers to build systems. Nobody has to spend weeks trying to code to get two things to talk to each other. Also, 1815.2 provides cybersecurity using SAV5 and eventually SAV6. It also provides full scheduling capabilities. 1547 has some initial scheduling capabilities. MESA's work incorporated into 1815.2 provides much more scheduling capabilities.
Hey Darcy, we got a couple comments in chat to switch to full screen presentation mode.
Ah, thank you. Hmm. I think I could use an assist. I thought I was in full screen.
Where you
Yeah,
were on the display settings, just go swap.
Ah, thank you. That's where I thought it was. Appreciate you guys pointing that out. All right. Well, hopefully, is that better for folks?
yeah, that's better.
Awesome. Thank you. Okay. Moving on. All right. So the history of 1815.2, it started with 1547 functions, which includes Rule 21 for those of you in California. We added in 61850 semantics and functions. And then we took the MESA DER specification, which included additional functions, which I'll give you a quick hit on that in a second. And then added the DMP3 app note, which maps the 61850 data objects to specific DMP3 data points. So if you wrap all of those together, you get 1815.2. And as I mentioned earlier, we're expecting it to be released in early February. Okay, and here are the functions. I'm not going to go through each of these, don't worry. Just wanted to demonstrate. On the left, you'll see the 1547 and Rule 21 functions. Those are probably familiar to many of you. Wanted to show the additional functions that are coming from the MESA DER specification and are now incorporated into 1815.2. A lot more functionality, and what is most important to a lot of you is more capable scheduling. And Frances has more info on the functions. She'll be going through those in more detail. Before I hand it over to Frances, just a plug for adopting 1815.2. We finally have a standard, an international standard on the horizon here that's been vetted by everyone, utilities, vendors, EPRI, and gone through an IEEE process. It creates clear expectations for communications. Utilities know what to expect, vendors know what to expect, and it can reduce the time and costs of integration and just really reduces that that coding that can happen at the end of right before you're commissioning. It also it helps conformance with other IEEE standards. 1547.1 already references 1815.2, and the revision that's underway now of 1547 is also expected to include 1815.2. And for those who are looking over the horizon and thinking about transitioning to 61850, using 1815.2 is a great first step because the points list names are directly mapped from 61850. Okay, with that, I'd like to hand it over to Frances. And Frances, a quick reminder just to introduce yourself for those who haven't had the pleasure of meeting you.
Okay, my name's Francis Cleveland. I'm president of Xanthus Consulting International, and I've worked in this space with IEEE as well as IEC for many, many years, particularly focused on distributed energy resources that typically include inverters. Sometimes people use the term inverter instead of DER, but the DER is the more general term. I was just responding to a chat message. Anyway, I will start getting into some of the more gory details of 1815.2 so that you can see how it functions, how it works, because I think it's important to get some of that. If I can't get to the details enough, you can always ask me for more. Okay, next slide. Okay, the first thing is, as Darcy said, we really focused on first the 1547 functions, because those were clearly going to be needed. And what we did is we have a table, and I'll get a little bit more into some of these details as to how it works. But you can see over on the left, we have the functions, some of the nameplate information, down then to the basic functions like connect, disconnect, cease to energize, voltage ride through, charge, discharge, active power limit. That's a big one these days. And then you can see over on the right-hand side the DNP3 points that are listed in a spreadsheet. At the moment, they're all in a spreadsheet. We expect to move to JSON or some other similar kind of capability, most likely JSON. But for right now, because of the history, we have it in a spreadsheet. And what you can see is that there are fixed points, so that if you look at connect, disconnect down here in the middle, you will see that analog input 60 and 61 are always related to and mean what connect, disconnect is, and then the other similar ones are the analog output 16 and 17. What I'm really pointing out is how interoperable this now is. Anytime the DNP3 point AI60 is received or set, it means the same thing, regardless of what utility is involved, regardless of what DER system is involved. That's the important aspect for interoperability. It has to mean the same thing all the time. Okay, next slide. So this shows part of the spreadsheet itself, and you'll see over on the left is the DNP3 point index, and it goes from 0, 1, 2, 3, etc. And then it shows in the spreadsheet exactly what the meaning of that, in this case, binary output point really means. So, and as you can see, it's linked to the 61850 names. This allows the system to be interoperable with 61850 names. I won't say the actual protocols are interoperable. They're very different. But the names are the same, so that there can be an easy mapping between the two if you so need to do so. Or for that matter, if you have some DNP3 point DER systems and also some 61850 systems, say in a substation or something, you can easily map between the two. So next slide. So here is just a little bit more complicated part of the spreadsheet. This is for analog inputs, again, starting at A0, AI0, AI1, and so forth. And if you click again, you will see that it's the DNP3 point lists and the 61850 ones, so that there's, again, a very direct correlation. I will also point out that some of the other protocols, such as IEEE 2030.5, also use the 61850 as their base, sometimes with slight changes in their the way they're expressed, but they're the same points with the same meanings. So we're really beginning to come together, at least in the semantics, the meaning of particular points. So this means that even with IEEE 2030.5, there can be an easy mapping between the different protocols. But we're talking DNP3 because so many utilities use that and need that for SCADA-like interactions, in particular, the larger systems It can be for an individual DER. It can be for a whole site of DERs with PVs and batteries and even wind and loads, controllable loads. So all of that works together here with these DNP3 functions. Okay, next slide. So here are just some examples. I don't want to go into some of the details of that, but I just wanted to be able to show you how we have the spreadsheet. So you'll recognize the upper left is the spreadsheet for active power limiting. Then we have the actual 1815.2 document, which describes, if down at the lower left-hand side, exactly which points do what for the active power limit function. So we have the description. We have optionality. If you've already set this, you don't have to set it again. But the idea is these are the steps that need to be done to actually do the active power limiting. And then we have some illustrations showing how the active power limit function actually operates. So we have descriptions as well in the 1815.2 document, as well as just the point lists, because it's really important to understand how a function is expecting to work rather than just have a raw set of points. Okay, next slide. So this is the same thing. I don't show the spreadsheet, but I'm just showing some of the diagrams for peak power limiting, load following, generation following, and the various points here on the right that would be used to set that. I'm hearing that there is an increased interest in generation following. That's basically batteries following PV systems so that they can provide a more constant output, but there can also be load following where the generation follows load, either for limiting it or simply to smooth out the loads as well. So again, we have all the points necessary to handle those functions. Okay, next slide. The spreadsheet is rather detailed here. I obviously you shouldn't be looking at the spreadsheet to see it, but the point is that the frequency watt droop function is actually just one version of having a frequency measurement and then responding by some watts. So the droop function is the most common one and is in 1547. But the frequency watt function can be used for other things like fast frequency response and a few other functionalities. Europe has different requirements than the US, at least at the moment. So we're trying very hard to make sure that we meet not only the US requirements or North America, maybe South America as well, but also European Far East requirements as best we can. And we're picking up on the IEC 61850 requirements for that very reason, because that's a very international committee that's really trying to follow everything around the world, not just Europe. So we're trying to cover as much as we possibly can and provide the flexibility to meet the slightly different standards that arise in different countries or regions or whatever. Okay, next slide. So this, again, I mentioned that Europe has some different requirements and ones that are not in IEEE 1547, but could be in the future. But in the meantime, we're providing the kind of capabilities that Europeans also require. Okay, next slide. So one of the things that we're also working on, and the reason I'm bringing it up here, is it is still experimental, and we have a couple of these experimental functions, but this one is synthetic inertia. We've had one utility working on trying to implement synthetic inertia in their battery systems. Um, and it's kind of a challenge because there is no single functional requirement that has been clearly defined. Remember, we're just dealing with the communications, not with the functions per se. So we need to have the functional requirements more fully defined for some of these more experimental types of functions. But we're trying to provide at least some capabilities to be used. And then we've got places in the spreadsheet where you can add points or, well, not modify. We want to keep the ones that are there at fixed because that's the interoperability. But you can add points and use different points as you try to do experimental functions. So we have room for that. We also are kind of waiting to see what the industry does with some of these newer functions that are clearly going to be important, but are not yet functionally well defined. Okay, next slide. Um, so this is the management of schedules. So if you go to the next slide, first of all, it's become clear that scheduling is becoming increasingly important. And we've seen this in California. I just was on a call this morning where the Europeans and the IEC were talking about needing scheduling for their DERs and their loads. So, because it's really important for utilities now to have a firmer understanding or a firmer ability to be able to limit loads, limit generation, or at least at the point of common coupling. So we've developed schedules that can work for setting firm export limits, firm import limits, again, with data centers and PV, rather the EV stations, charging stations to limit the imports, and also have the ability to change these schedules or to have a base schedule with overriding newer schedules based on, say, non-firm export capability, because things change by the day. So you can have a base schedule set by the utility as sort of the default, and then you can have changes to that based on current weather conditions, current situations in the power system, etc. So this is coming in California, and we've got a number of other types of functionality that is really going to be important for using scheduling as a major tool for ensuring that the power system stays operational. Okay, next slide. So this is an example from California of the limited generation profile, where what you can see is that the utilities, a year or so ahead of time, will try to establish what their limits are going to be. And that can be this red dotted line is what the utilities, based on the yellow information down below, what they expect the limits to be. But the reality on a day-to-day basis is very different, as you can see. And so the limits can be modified on a daily basis, on an hourly basis, to allow additional capabilities. So the scheduling still might be done day ahead, still might be done hour ahead, but it can also be spot market. That sounds like transmission, but it also can apply at the distribution level. So this is what California is working on at this point in time. Okay, next slide. Okay, again, a lot of gory details, but one of the things that has been always an issue with scheduling and setting schedules is how to define them with a fixed set of DNP3 points, because this is now getting back to the fact that we need to use the same points to mean the same things. But what we've done is we've come up with a scheme where we can have schedules. Looking over here at the diagram on the right-hand side, you can have schedules, multiple schedules, as you can see, schedule 1, 2, 3. But when you're going to modify a schedule or add it in the first place, you bring it into a set schedule editing points. In this case, analog output 3000 to analog output 3408. So those become the fixed points where you can update a particular schedule. When you've finished updating it or defining it, you essentially say, okay, it's done. It goes back to the database. And now those points, those same points, are available for updating other schedules. So this was an important way of dealing with the fact that we could have, in fact, we allow hundreds of schedules, and each schedule can have hundreds of points depending upon what type of schedule it is. If it's an hourly schedule for a year, it would be one thing. If it's a daily schedule per hour, so it'd be 24 points. We're allowing all of that flexibility so that people, systems, utilities, and DER vendors can implement them as needed, as they need to do this. So, and we have all of the capabilities needed for this. Again, I was just talking this morning about the scheduling requirements in Europe, and we're trying to modify those to meet the same kinds of things we have already put into 1815.2. So I'm hopeful that the IEC will actually follow suit on this. Okay, next slide. Okay, so this gets into the testing.
So over to Tyler.
Yeah, so I want to just pass it over to Tyler and let him pick it up from there.
All right. Thank you, Francis. My name is Tyler Slay. I've been with P&L for just over 3 years now. I have been working on pretty much all of the protocol standards that are outlined in IEEE 1547, so 2030.5, Sunspec Modbus, and primarily of MESA DER to the IEEE 1540 or 1815.2 standard that is soon to be published. So the testing and certification process is carried out in partnership. MESA and UL are working together for this testing and certification program to outline a 3 separate steps. We have the semantic tests, and the semantic tests validates the relationship with data. So how does a device interpret information being sent from a control station? Does it map it internally correctly? Is it, as we outlined with the scheduling, is it multiplexing those schedules correctly when it gets a switch command to go to a different schedule index? And is it enforcing the maximum upper and lower bounds of the point in particular? And is it scaling that point correctly? So that's all included in the semantic tests. And then you get into the functional testing, which is outlined in the 1547.1 UL 1741 SB procedure by UL. That says, okay, now that you've received the data, do you know what to do with that data so that the internal information that you are storing actually results in external behavior that we're expecting? So that's where you're making sure that the control modes are prioritizing correctly, you're switching between your schedules and curves correctly, that your device is responding to, if you're on a frequency watt or a volt var control mode, you're responding to those voltages and that frequency deviations on the grid. And if you need any help, we just refer back to that slide 10 that outlines all of the functions, because all of those will be outlined in that 1547 control modes. The commissioning test is kind of its own beast. This is where the device is tested, but its requirements are heavily dependent on the utility you're working with, local area regulations. So we can't specifically say what is going to happen, but that is another step that we will work with whoever the regulating entity would be to determine what the actual procedure would need to be for that actual commissioning of the facility, most likely that's going to be commissioned. Next slide. All right, so this just goes a little bit deeper into kind of the bodies that are going to interact with the various tests. So when we get to the semantic tests, you can use either our P&L's open source test tool that's going to become available once the standard is available. It will be available to MESA members first as beta testers, but then it'll become just open to anyone once we've kind of fleshed out the functionality. We also have the Triangle MicroWorks test tool that was previously created for the semantic testing. And both of those will ingest a PIX datasheet in the spreadsheet form, and the P&L test tool will also ingest it in JSON form, which is what we're trying to move towards because it's a little easier for computer ingestion than the spreadsheet. Also, the semantic testing does recommend that you work with the DNP3 protocol and cybersecurity certification, which is covered by the DNP user group. It's not technically required, but it will be very helpful to ensure that you're speaking correctly before you're worried about what the data is inside that, what you're saying. In the 1815.2 functional testing, that's where we're taking the functional test procedures from 1547.1, which is UL 1741 SB. We are a superset of 1547.1, so we do all of the controls outlined in 1547.1 and then add additional ones. So we are working with UL to ensure that the current testing procedures will translate directly to the additional control modes, and if they don't, then we'll come up with whatever additional test procedures need to be outlined and either make another amendment to 1741 or have it as a separate control test procedure. But the functional test procedure, as I said, covers all of the actual functions, and it is required to be passed by a NERDL, which is a nationally recognized test laboratory such as UL. And then when you get into the commissioning, again, this is going to be going to require that you've already passed your semantic testing. Also requires that you passed your functional testing. So if you have a plant or device controller, that should have already went through testing. But now when it's in the field, that's where you have to work with your utilities, your regulating bodies to determine if there's any additional interconnection requirements that you need to accommodate. Next slide. And this is a overview of all the certification entities. So at the very top, we have the DNP3 user group. So they cover the DNP3 protocol itself and this security specifications. So SAV5 and sorry, we went back. There we go. SAV5 and soon to be SAV6 once that gets released by the user group. We have the semantic profile test, which is kind of covered by the UL/MESA working together with our test tools. We have the 1741 SB for our functional test procedures, also covered by UL as the certifying entity. And the 1815.2, that's those additional functions that we are adding on top of 1547.1 that will cover will also be covered by UL, but to be determined on how that fits in with the 1741 SB, because they are new functions, so they may need to have some amendments. And then we get into the 1815.2 commissioning. Again, it's going to be very dependent on regulation, area regulators, utilities, but same basic concept. I think that's it for the testing and certification.
It is. Thanks, Tyler. I'm just going to touch quickly on the benefits of becoming a MESA Standards Alliance member. First and foremost, you get access to the 1815.2 standard and related spreadsheets. MESA has a sharing agreement. Our intellectual property is incorporated into 1815.2. And so our members have access to the standard. The standard will evolve. There are many things that were set aside in the work group that are not incorporated into the current iteration of 1815.2 that will be addressed in future versions, and MESA will be at the front of that. You also get access to the experts. You've just been listening to a couple of them who are actually writing the standards, and you get a community of folks who are implementing the standards, and you get lessons learned as well as advice, and also application notes, use cases, lots of community here where you can learn more about how to do this and do it well. Most companies come in at $5,000. We do have a small business member and a joint SunSpec Modbus membership that gets you a small break if you do joint membership. And if you have any information about this, let me know. Just reach out to me and I can give you more information. We also ask, primarily our utility members provide technical allocations. This is actually, our membership fees do not cover this work. We need companies to provide funds, usually from R&D budgets or project budgets. And those usually come in 5,000 increments. If anyone can make additional technical allocation, that's incredibly helpful. This is our contact information. I will be sending this presentation out as well as the recording, so you don't need to write those down quite yet. But I wanted to have plenty of time for questions, and I think we've managed to do that. So I want to open the floor, and we have about 15 minutes. So if you can just raise your hand, then we can call on you. I do see one question in the chat. Francis, what are the ways that this mapping between 61850 and DMP3 will be used in configuration tools?
Yeah, I've been responding to the previous emails or chats as well. Yes, so because we have the spreadsheet with the 61850 names, we don't have a specific configuration tool. We just have the test tool to ensure that whatever is implemented by a particular vendor meets the 1815.2 requirements. We may move to something where 61850 and DNP 3 is more tightly coupled if we see a particular need for it. At the moment, we're just worried or trying to establish the fact that the semantics are the same and that people will then implement mapping tools if they need it, or simply awareness of this is the functional requirements, and here are the communication requirements, whether 61850 or DNP3 using 1815.2.
I did want to tag in there. The test tool, the P&L open source test tool, does have a configuration feature where you can filter by protocol, filter by 1547 functions, and filter by 1815.2 functions, and create your schedules and curves. It even has a nice little front interface for showing all of the schedules you currently have, how they align from start time to end time. So that will be, I think, very helpful for people who are trying to play around with these configuration PICS files, whether you use JSON or the spreadsheet.
Yeah, there's another question in this chat before maybe we get to Bruce or others, where it says, the question is, a simple DNP device 1815 can communicate with a DNP device 1815.2 by pointing data to the right point defined in the semantic model. And the answer is basically yes. I am sure that there may need to be some additional configuration requirements and so forth. But basically, that is the whole purpose, that you can use DNP3 so long as it uses the defined point numbers for specific requirements. Okay. Darcy, is Bruce the next?
Yeah. Bruce, why don't you jump in next?
Oh, great. Yeah, thank you very much for the very clear presentation. So originally, decades ago when people started on this, I think the idea was there was one inverter in the building and that was it. But now, of course, we may have in the future, a dozen inverters in a building, not only stationary batteries, vehicle chargers that are bidirectional, plug-in solar, plug-in batteries, loads with integrated batteries, in which case it sort of suggests we'd have maybe a gateway function that receives and redistributes commands. And also, you've talked about functions that require coordination with what's going on at the meter at the point of common coupling. And I was wondering if you have any comments on sort of any tensions that creates and sort of newer architectural principles that address the fact of going from a single inverter to no limit to how many inverters might be at a single site. Thank you.
Okay, Darcy, can you go to slide 6?
Yep, I figured you might want to do that. Hold on.
Because, Bruce, I think this is where we've made sure that we're, in fact, always able to meet the requirements not only of individual DERs. So I will pick up where Darcy just had a very brief overview. But for instance, if you take a look at the left-hand side and you see the utility transmission system operator, distribution system operator, SCADA system, they can work directly with an IBR, inverter-based resource, and or a DER plant, where it's just directing what happens at the point of common coupling. Or it can go through a utility gateway to, say, an aggregator, because many of the smaller systems, or many of the systems, also work through aggregators. Or it can go through directly to a facility plant. So it would have a facility gateway and a facility energy management system, which in turn would be managing all the behind the meter DERs, maybe EVs, as well as loads now, more and more, so controllable loads. So we've designed 1815.2 to be able to treat individual DERs as well as whole plants. And that was part of the whole design process, the need to do that, because we recognized right from the beginning that indeed we needed to be able to treat a facility as a DER. Maybe just looking at the point of common coupling or the reference point of applicability. however you want to phrase it. But yes, 1815.2 can work in any one of these configurations.
Oh, great. Excellent. That's great news. So yeah, I guess my thought is that, to call, if we're only talking about inverters, why not just call them inverters? But also, when you talk about the site as a whole, you may then have non-inverter devices contributing to things like managing import and export capacity. And my proposal for what to call the facility as a whole is just call it a customer, because I think that makes clear what the entity's relationship is to the larger grid. But anyways, thank you very much for your presentation.
Okay.
Thanks, Bruce. We have a question in the chat, and Tyler, this goes over to you, about Voltron.
Yeah, so currently we are in development of an interoperability agent, which has not only 1815.2, but 23.5 and SunSpec Modbus agents. They all speak 61850, 7420. So they use that because that is the common mapping between all of the protocols. So yes, it will include, it's still in development, but we're getting very close to getting that out the door. Oh, thank you, Craig. Craig's on it.
Thank you both for chiming in. Other questions? We still have a few minutes.
It's glad we said the same thing.
Yeah, I didn't throw you under the bus.
All right, feel free to type your questions in the chat or raise your hand. Okay, is 1815.2 an alternative solution to 2030.5? Can you break down a few ways in which they are different and where they are the same?
Okay. That's one of the biggest questions that often arise. I would say that basically 1815.2 can be used anywhere that 2030.5 can be used, because they have, the 1547 functionality capabilities. But there are a number of areas where DNP3 is more appropriate. In some cases, it's because the utility is looking, and you can see it in this diagram, is really looking for SCADA-like interactions, so that there's a very direct interaction, second by second, sub-second by sub-second, and the utility's SCADA systems are already set up to do that with DNP3. So it makes much more sense, certainly with these larger inverter-based resources and the DER plants, again, a full plant, not just an individual unit, to use 1815.2. In addition, 1815.2 does have some capabilities, like the scheduling capability that at the moment 2030.5 does not really support. I've been told that they're working on it, and that would be good news. But it is true that the scheduling that's provided by 1815.2 is far more capable than that provided at the moment by 2030.5. The reverse of that, and I will say this quite bluntly, is that DNP3 is not a internet friendly protocol. It was developed long before the internet was ever used, and 2030.5, on the other hand, is internet friendly in that it's designed really to work with systems via internet or internet-like communications. But that said, still DNP3 can be used anywhere that 2030.5 can be used. So that in a nutshell, there's a lot of details, but that in a nutshell is sort of where 1815.2 fits in the picture of communication protocols. And just to add something, in 1547, DNP3, 2030.5, and Modbus are also mentioned or included. And I believe it's pretty clear that Modbus can be used locally, like over on the green side, the right side of this diagram. That's where Modbus would be used. I don't think anyone would really have extensive communications from the utility to the DER systems using Modbus. I know there's some examples of doing that, but Modbus does not have the security or the flexibility to do some of the requirements for that.
Thanks, Francis. Ryan, let us know if you have any follow-ups. Another question, does 1815.2 include DMP3 SAV6? That's the cybersecurity.
Right. And the answer is 1815 itself includes SAV6. That's in process. There's still work. SAV6 sort of comes in two pieces. One piece is part of 1815 itself, DNP3. So whatever's in 1815 itself, 1815.2 can use. The concern, though, and this is an ongoing debate, is that there is another piece to security. SAV6 really needs something called AMP. I won't get into the gory details there. And AMP has not yet been fully defined, and it needs to go through a full definition and then testing and all of that. And that is probably a year or two away from now. So, although SAV6 portion that's in 1815 itself could be used, it's not very expandable until the AMP capability is also defined. So that's a long answer to that, but whatever's in 1815 itself can be used by 1815.2. There's nothing that says you can't.
SAV6 is defining AMP. It is still going to be in its infancy and needing testing. So I think there's still a little bit of ways to go before you're going to see an SAV6 actually defined in the standard as a requirement, because it's still in development.
Right. There's some debate about that, but that's kind of where it stands right now. So what do we now use for this? The basic answer to me is you really have to use SAV5. It's not the easiest security to use, but it does work with a few modifications that are defined in the DNP user group. They have a technical notice, technical document that defines what you need to do using SAV5. Clearly, you can also use simpler approaches like VPNs. They're not as secure because they don't do it. They do it across the media, but not to the application level. That's really the debating point right now. As to which one should be used. And I think it might depend upon what the circumstances are. If it's just essentially, for instance, the SCADA interactions with the IBR, you might go ahead and try SAV6, even if it's not fully tested, because you'll only have one or two of them, just a few of them. You don't need the full AMP capability. But if you're going to be running lots, 50, 100 plants that are going to use DNP3, I would suggest sticking with SAV5 for the time being.
Great. Thank you, Francis, and thank you, Andrew, for chiming in on the text too. Appreciate that. We're at the end of our time. I want to thank everyone for participating. If you have additional questions, please feel free to reach out. And we hope that we will see you in a future session. Thanks, everyone.
Bye, everybody.
Thank you.